All right, so in solving systems of equations using substitution, the very first thing you want to do is pick one of your equations and solve for a variable that is in the equation. The easiest one to do would be the variable that has 1 as a coefficient. If that is possible, sometimes it is not. So let's take a look at our first problem here. In this problem, the first equation, x has a coefficient of 1, so we're going to solve for x, adding z to the other side, which gives us z plus 3. Now, the second step is then to take that value and substitute that z plus 3 into the other equations. Now, the second equation does not have an x, so we will just write that down as 2y plus 3z equals 5, and we'll leave that alone for a minute. The third equation does have an x, so we're going to substitute z plus 3 in for the x using parentheses for our substitution. And we always want to put what we're substituting into the parentheses. All right, so we're going to have z plus 3, and then minus y equals negative 6. Distributing the negative will be negative z minus 3 minus y equals negative 6. And we want to move the constants together, so we're going to add 3 to the other side. So we have negative z minus y equals negative 3. Now, one thing to recognize here is that all of these terms are negative, so we can make this a little bit easier on ourselves and divide everything by a negative 1. That will simply turn everything positive in our equation. So now we are down to two equations, this one, and we have two variables, y and z. So we're down to two equations with two unknowns instead of three equations with three unknowns. So once we come down to this point, we repeat the process, which means our next step is to pick an equation and isolate one of the variables. So I'm going to pick the y value right here and solve for y. That means we'll be subtracting z, giving us y is equal to 3 minus z. We'll now take that 3 minus z and substitute that into this other equation in place of y. That will give us 2 times 3 minus z plus 3z equals 5. Now we need to distribute, so you get 6 minus 2z plus 3z equals 5. Combining like terms and solving for z gives us z equals negative 1. Now that we know what z is, we can substitute it back in to this other equation and find out the y value. So y is equal to 3 minus that negative 1, which is 4. We can also substitute negative 1 back up into our first equation, giving us x equals negative 1 plus 3, which is 2. And we always write our answer as a coordinate, putting x first, which is 4, then, that's the 2, then the y value, which is 4, and then the z value, which is negative 1. And that is our solution. So let's look at the next problem here. Picking a variable to solve for, I would probably pick the x in the second equation because it has a coefficient of 1 right here. So that will make this x is equal to 4z minus 3y minus 7. We now take this value and substitute it into the other equations for x. So substituting into the first equation will give us 4 times 4z minus 3y minus 7, and then minus 2y plus 3z equals 1. And then we also substitute into the other equation for the x, giving us 3 parenthesis 4z minus 3y minus 7 plus y plus 2z equals 5. Now we'll distribute. And combine like terms. So 16z and 3z is 19z. Negative 12y minus 2y will be minus 14y. We'll move the 28 over to the right by adding it, giving us 29. So moving over to the right, we're going to distribute. And then combine like terms, 12z and 2z is 14z. Combining the y's will give you negative 8y. And then we'll add the 21 over to the right, giving us 26. Now for simplifying purposes, if you look at this equation, all 3 terms are even. So I can reduce this equation by dividing everything by 2. That will give us smaller numbers to deal with here in a minute. So we have 7z minus 4y equals 13. All right, so we solved for a variable. We substituted it back into the other equations, and then we distributed and simplified both equations. We are now down to 2 equations with 2 unknowns. So we repeat the process. Now this time we do not have a variable that has a coefficient of 1. So it's not going to be quite as easy, so we just need to pick a variable and solve for that variable. I'm going to use z right here. So solving for z will give me 7z equals 4y plus 13, and dividing gives me z equals 4/7 y plus 13/7. We'll now take this and substitute it back in to this equation for the z value. All right, so that's going to give us 19 times 4/7 y plus 13/7 minus 14y equals 29. All right, distributing, 19 times 4 is 76/7y. 19 times 13 is 247/7. 19 times 14 is 260. I'm sorry, we don't have to multiply those together. That's just going to be minus 14y equals 29. All right, so our next step is we want to simplify this equation a little bit. So we're going to multiply the whole equation by 7 because that will get rid of the fractions here. So multiplying by 7, this becomes 76y plus 247 minus 98y equals 203. Combine like terms, 76y minus 98y is negative 22y. Subtracting 247 over to the right will give us negative 44. And dividing gives us y equals 2. So we can now take this 2 and substitute it back in for the y value here, and then solve for z. So now we have 4/7 times 2 plus 13/7. So z is equal to 8/7 plus 13/7, which is 21/7, and that is equal to 3. Now we can go back up to our original problem up here, and where we solved for the x. We know our z value and we know our y value, so we're going to substitute those values in right here. For the z, we're going to put in 3. For the y, we're going to put in 2. That will give us x equals 4 times 3 is 12, 3 times 2 is 6, and then minus 7. Therefore, x is equal to negative 1. And our solution will be the x value, negative 1, then the y value, 2, and finally the z value, which is 3. And that is our solution here. And one last problem right here. All right, so here we already have a variable that is solved for. X is equal to 3z minus 5. So the first step is already taken care of. All we need to do now is substitute this into the other equations. So substituting into the first equation will give us 2 times 3z minus 5 plus 2z equals y plus 16. And then substituting into the other equation gives us 7 times 3z minus 5 minus 5z equals 3y plus 19. All right, distributing and combining like terms. So we're going to have 6z minus 10 plus 2z equals y plus 16. All right, combining like terms, we'll have 8z. I'm actually going to subtract 16 over to the left side, which will give us minus 26 equals y. The reason I did that is because in one of our next steps, we're going to have to solve for one of our variables. And so by bringing the 16 over to this side, I'm solving for the y. So it kind of will help me in that next step. All right, so distributing over on the other equation is going to give us 21z minus 35 minus 5z equals 3y plus 19. Combining like terms is 16z. I'm going to bring the 3y over here. I'm going to add the 35 over to the right, which will give us 54. All right, so now this is equal to y. So I'm going to put that over here in place of the y. That will give me the equation 16z minus 3 times 8z minus 26 equals 54. So now distribute, give you minus 24z plus 78 equals 54. So we'll have negative 8z. Subtract 78 over to the other side is negative 24, giving us a z value of 3. I can now take this z value and substitute it back in, which will give us 8 times 3 minus 26 equals the y value. That's 24 minus 26, so y is equal to negative 2. I can also bring this z value up here and find my value for x. So x is equal to 3 times the z value of 3 minus 5, so 9 minus 5 is 4. Writing this as a coordinate for a graph, x value, then the y value, and then the z value. That is our solution.